Okay, what's up everybody? This is Ryan here. So today I'm going to be working on the parser for my compiler for my programming language. So I'm not going to ramble for too long here because I got to get coding. I have a lot of work to do. But just understand this video is a follow-up to the previous live stream I did where I was building the Lexer with test-driven development. I didn't end up building the entire thing on camera. There was some work that I did off camera. So what I'll do is I'll just show you what that looks like, and then we'll get into writing the parser. And one really important thing, if you're watching the recorded version later, especially with this parser here, don't look at this as like I should be copying exactly what Ryan does, because this is my first time writing a parser. And while I have been to a large extent following the same sort of ideas and code structure as Bob Nystrom, who wrote Crafting Interpreters. My code is getting more and more far removed from his implementation. In particular, I'm trying to avoid shared mutable state. So for example, global variables entirely, and that means I have to really structure the code in a different way. So basically what I'm saying here is I'm experimenting, but I'm going to be guiding that process using tests, which I write, generally speaking, before production code. So you'll get to see test-driven development in action. So anyways, I don't want to ramble full webcam mode here longer than that. What's up, Sean? So let me just make some adjustments to my screen. Something like that. Also, I'm, for the moment, only using one monitor here, so it's been quite an adjustment. I, for many years, used two monitors. Okay, so let me just run everyone through what I did with the scanner, and maybe also give a brief explanation of what a scanner is, just to give some educational information here. So basically we have what is typically referred to as like a front end of a compiler. Now in fairness, this term front end seems to be a little bit confused, but what I've taken to understand it means so far is basically three things. You've got sort of, generally speaking, two stages of processing. So you've got like a Lexer, and then the next stage is a parser. So in the Lexer, you're taking source code. Let me kind of do it like this. So in a Lexer, we're taking source code. So that's just the language you're writing, the source of the language. And then you're converting in essentially, effectively into a list of tokens, language tokens, and I'll show you what those are in a second. And then for the parser, we're basically, as far as I understand, taking the list of tokens that we got from the Lexer or scanner. This is an annoying thing, but you'll see this in every kind of programming discipline ever, is that there's multiple words that refer to the same program. So both the scanner and a Lexer, they're a program which reads source code and generally speaking will output tokens. And then from what the parser will do is it'll look at the tokens that our scanner has generated, or Lexer, or whatever you want to call it, and then it should produce, I believe, an abstract syntax tree, I think is what I'm trying to do here. And then I'm not super familiar on the next step, but I believe the next step is the like the runtime environment or the interpreter or something like that. But I'm not going to get into that until I start actually learning about it. So today what we're working on is the parser. Let me show you, I'll walk you through the what we've done already with the scanner. So the most important thing is, so we've got this thing called a scanner, and I'll just show everyone, this is the kind of stuff you might want to learn from me, building loosely coupled application code. So I put my scanner and also my parser, both of them are behind interfaces. And the reason why I did that is I might want to change from my handwritten scanner or my handwritten parser to a library that does that. So by hiding these things behind interfaces, that's going to be really easy. Now, like I said, a really important thing is that I chose not to use shared mutable state or global variables for either of these things. And in order to do that and handle errors, I basically had to, or decided to create my own specific exceptions for each component. And then we also have a result wrapper, which can either represent a successful parsing or scanning of some source code, or it can represent a list of errors that can occur. Now, one thing I learned pretty early on when you're writing a compiler is that you want to be able to catch multiple different errors. You don't want your application to just basically crash out and tell you one single line is an error. If you can give the programmer more information, so multiple different lines where an error has occurred, a syntax error, for example, then you're going to save them some time. So we pass some source code in, and I'll show you what that looks like in a minute, into the scanner, and the scanner will turn that source code into tokens, or it will explain why it couldn't turn the source code into tokens. So that's kind of what it looks like. It's just got one function here, but as you can see, it's a pretty hefty file. Something like, oh, voice is a bit low. Okay, 1 second. Thanks for the feedback there. I might just be talking quietly. Could be that. Recording. Okay, I'm at 100% and boosted, so it's got to be your and on your end there, Swaminath. Anyways, so yeah. If another person could confirm that the audio is quiet, it doesn't look quiet on my end because this is indicating down here that it's pretty loud. Anyways, so yeah, how the scanner works is we give it some source code, which just gets passed in as a string. And then we kind of loop through it and we chop it up into tokens essentially and collect any errors along the way. So the way that I built this thing was using test-driven development. My definition of test-driven development, so some people are like kind of TDD zealots, and they'll say you should never write a single line of code unless you have a failing test ahead of that. I think that's a little bit ludicrous at times, but it's a good general rule. I think it's a principle, not a rule. But generally speaking, I did write a test before I implemented something in the scanner. Now what I would do is I would write some source code in my language, donk language is what it's called, and then I would give that, that source to my scanner here, and then I would basically create an expected result, what I wanted to see it output, and then I would make sure that it outputted the expected result. And then once that would pass, then I would move on to another kind of thing. Now, an important thing to note is here's what our tokens look like. So they have a value, they have a type, which I'll show you in a second. They have a literal, which is only used for numbers and strings. And then they have a line, which I didn't end up using that at all. I'm not actually sure if that's important, but we'll see. And then really importantly, we have the token types. So earlier I said that the scanner / lexer takes in source code, so something literally like this here, takes in the source code of the input language, and then it produces a list of tokens. These are the tokens that it produces, the token types. And these have to essentially represent every single individual element in a language. So we're talking about brackets, parentheses, exclamation marks, so not, identifiers, strings, numbers, that kind of thing. And identifiers like something the programmer decides on, like the name of a function, for example. So yeah, all those things come together to form a list of tokens. Just going to drink some coffee. Apologies that you have to hear me drinking. Okay, so this was the scanner, And at least last time I checked, all the tests were passing, and there's quite a lot of tests. I wanted to test for every kind of token, essentially, but all the tests are passing, at least last time I ran the tests. My English is terrible today, and I don't know why. And yeah, now we're writing the parser, which is the next stage. So let's just see where I've gotten started here. So we don't need these interfaces open. I do need the parser tests. No worries, Swamanath. So I've set up a primary test class, and of course the process for testing is you create a real version of the thing you want to test, you give it fake data, and then you see how it behaves. You make assertions about its behavior. So that's basically what we're doing. Now, the thing that was really tricky with writing this parser, let me give you a quick example. I'm going to go to the language specification, which is kind of like a written form of the language. So the difficulty that I ran into is I need to write what's called a recursive descent parser. So it sort of starts at the top level of the list of tokens. So that would be something like a function declaration or a class declaration. I don't have classes in my language yet, and I probably won't. I'll probably use something like tuples, but we'll see. But yeah, it starts at the top level, and then it attempts to parse out the source code. So this is a line or a statement of source code in Donk language. This is my programming language. I do have to make one correction here. We're not actually going to do types, at least initially. I do have 3 main types, but I'll get to that later. So anyways, we have our line of source code, and basically what we do is, just one sec, we need to look at it sort of from the top level. So our parser is going to see that there's an instruction here, which is like a top level declaration, and then it's going to expect to see an identifier, so the name of the function. It's going to expect a parameter list. It's going to expect basically the function block. Depending on if it has a return value, it's going to expect a return statement, etc., etc. Hey, what's up, Ashish? So the difficulty here is originally, in terms of test-driven development, I started this out by trying to parse a function declaration, so one of these top-level things. So I created my source code in the form of a stream or a list of tokens, and then I set up that. And then after that, I realized, like, I don't think I can really approach building this thing top-down like that, even though in a sense it functions in a top-down manner. It's kind of difficult to describe. Let me just grab my whiteboard for 1 second. I was really thinking a lot about this today. Trying to get my microphone up here. Okay, just 1 second. By the way, if you're a programmer or a mathematician or something, you should really buy a whiteboard. I just find them super useful. Okay, so I'm not entirely sure how well you can see this, but basically what I'm trying to do here is, originally I was thinking of building this thing sort of from the top up, but I think what I'm actually going to do is I'm going to build it from the bottom up. So the first thing I'm going to try to add implementation-wise to my parser is a binary expression, and then a unary expression. And then once that's ready, I'll move into, say, for example, a return statement. And then a return statement is comprised of, say, the return keyword, a semicolon, and then an expression within it. So as you can kind of see, if I were to try and approach this from a top-down perspective, implementation-wise, this probably looks super professional, doesn't it? What I would have to do is, I'm not sure if I can explain it, but I'd have to build this out test-wise, and I don't think I could actually do that without faking a whole bunch of stuff. It's difficult for me to explain, but what I'm trying to say here is I'm going to approach this from a bottom-up perspective, implementation-wise, even though this is like a top-down parser. Ashish asks, how do we get benefit from your language? What do you solve for us? So I'm basically, to answer your question, the benefit will be me teaching you how to make languages if you're interested. As far as problems that I'm solving, the one primary thing that I'm trying to do in my programming language is I'm trying to make it very legible and easy for teachers. I don't at this stage plan to make a language which is meant for like production code. It's going to be meant for teaching, which is why I have the word instruction here instead of function or method, because instruction, at least for native English speakers, is a clear explanation of what a function is. So yeah, that's basically it. It's mostly an educational learning project for myself and then eventually my students and people who watch me on the YouTubes. Okay, so with that rambling done, let's see where we are in the tests. So I just finished writing the test for a binary expression, I think. So we have an example of a binary expression, which consists of 3 tokens. And how this is supposed to work is we're supposed to go from a series of tokens, like I said before, a list of tokens, and we're supposed to translate them into one of 2 things. Let me clear some room here. So we're going to be translating these tokens into either expressions, so subclasses of base expression, or what is my IDE doing? That was weird. They're either going to be subclasses of base expression or they're going to be subclasses of statements. Languages are, at a certain level of perspective, basically built of statements and expressions. I think how it works is an expression is a statement, but a statement isn't necessarily an expression. Whatever. Not the kind of stuff I really worry too much about. Thank you, Vidraj. So yeah, we're going to be taking in the list of tokens and we're going to be building out statements and expressions. And if I'm correct, this will essentially become the abstract syntax tree, unless I'm somewhat misled on that. Let me drink some more coffee. So yeah, that's where we are. So we have some test data here, a binary expression made up of some tokenized source code. We create our handwritten parser. It doesn't have much implementation in here, just very basic stuff. And then we have our test to test a binary expression. I think I can probably replace this. No, this is the expression, so okay. So this is an example. I'm actually going to pull this data out. Test data. I might even make a separate class for this test data because I feel like this is going to get pretty large pretty quickly. But we're going to say val binary expression tokens. And in case you're kind of wondering about testing, this is really what testing is. You have what you want to send into the thing being tested, the unit, and then you have what you expect to get out of that unit once it executes. And so really what you're testing is what happens in between, and you're making sure that a given result produces, a given input produces a given result. So this is our input and this is our expected result. The reason I just moved that up there is just because I wanted to avoid repetitious code. Okay, so binary expression tokens. Okay, so I'm just going to run this test to make sure it's well formed. you may have noticed I have the manliest cup ever. It actually says in there, no problema. My girlfriend bought that for me. All right, so I'm getting a not implemented error, which is actually good because that basically means we're just running into this statement here, which is in the parser. So this is a good thing. So this is the part where it's pretty difficult. So down in the link description box down below, you'll find a link to crafting interpreters. If you're interested in building languages, I highly suggest that book. It's free, it's online. I'm not paid to say that. Having looked at about 15 different tutorials on languages and compilers, it's really the only one that is well explained and useful and of a decent size. Now, with that being said, one thing that I've seen in every tutorial ever on compilers, which has been frustrating me, including crafting interpreters, is something called shared mutable state, or global variables specifically. I am not going to build a compiler that uses global variables. I don't like shared mutable state, and that's a primary decision. So the result of that decision is that I have to basically write this code mostly myself. I can't just copy and paste over from that example. So I just want to mention that my code is sort of inspired by the crafting interpreters, LOX language, but it's also quite different, especially implementation-wise. Not to mention that was written in Java, this is written in Kotlin. Now, one thing I saw Mr. Nystrom do, I hope that's his last name, I think it is he had this set of functions, so parsing basically a top-level declaration, and then if we're not able to parse a top-level declaration, then we try and parse a statement, and then if we're not able to parse a statement, we try and parse an expression statement. So we have this kind of sort of top-down approach, which looks pretty nice and clean. Now, the difficulty is, like I said before, he was using global variables. So he wasn't passing this stuff in. Like his functions, generally speaking, did not have any parameters. He was using the global variables to kind of work through stuff. I have to basically pass anything I want to work with, I have to pass it into a function. So this means I end up passing this data down the chain as necessary. So the result is the code is a little bit more verbose, but in my opinion, it's much easier to test, and most importantly, it's much easier to read, because I was really having trouble understanding how his parser worked merely based on the fact that it used global variables. Anyways, what we're going to do for now is I'm just going to worry about the thing I'm tested. I'm not really going to worry about other stuff. So I'm just going to worry about parsing an expression statement, which I believe is what we're looking for when it comes to a binary expression. Now, one thing I should note. I think what needs to happen is we need to return a binary statement. Yeah, so I really, I had a lot of trouble even getting started until I found his book. Like, the problem I ran into is that most of the tutorials I found, they either, that's not what I wrote. Most of the tutorials I found were either like really trivially small examples. Expression statement, I'm pretty sure that's a thing. XPR statement, I see. Most of them were like really small. Like this one tutorial, they made this tiny little, pretty much like a CPU language type thing, like literally push and pop type stuff. So that really didn't help me in building a high-level language. And then some of the other high-level language tutorials I saw used a whole bunch of libraries like Antler or Bison to generate the parser and lexer, and that also kind of irritated me. So In his tutorial, you actually handwrite the stuff, and he's good at explaining things, which is really rare in programming. Okay, so I believe we need to return an expression statement instead of just a binary expression. I just wanted to add that in. Now, let's see. I'm just going to remove this here. And I want to make sure my expected result is correct here. Yes, that should be correct. Okay, so now we're going to work on actually writing this code. And this is the part of the live stream where I'm actually going to be writing code I haven't written before, so this isn't going to be very exciting. And I'm probably going to be doing a lot of humming and hawing. But just one final thing before we get in here. In order to avoid shared mutable state, what I'm doing is I'm generally speaking returning pairs, which are essentially like tuples. So this is a way in the Kotlin programming language of returning multiple different values from a single function. Of course, you could write your own class for that, but Kotlin's pairs are part of the standard library, same as their triples, and it's just kind of a handy way for me to solve the problem. So, so we're passed in the current position, which starts at 0. We're passed in the current token, and then we're passed in the whole list of tokens that represent the source of this stage in the compiler. So that's what we're starting with here. Let me just format this. Hit Control-Alt-Enter. Sorry, Control-Alt-L rather, to format in IntelliJ IDEA and Android Studio. I'm actually working with IntelliJ IDEA here. Okay, so we need to be able to parse an expression statement. So the first thing I'm going to do is I'm going to ask myself, what does an expression statement start with, and what am I expecting? So I should expect something that looks basically, it's going to start with an expression, or it's going to consist of an expression actually. And then it should also consist of a, sorry, I think my beard ring is hitting the microphone. Apologies about that. Move that over. So yeah, it's going to consist of some kind of expression. Let me just double check that. Expression statement, yes. And then it's going to consist of a semicolon to represent the end of the expression. So that's where we're starting. Now we need to, in this case, cover our binary expression. So the first thing we're going to do is I'm going to kind of return some stub. So we're going to say return void statement. And then we actually have to return a pair here. So we're going to say pair, void statement, and then we're just going to return like 1, for example. So this is really actually just dummy data. I'm not actually trying to do anything useful. I'm just going to run that to see that we're getting sort of an expected failure. Okay, good. Now we're going to ask the question, what kind of expressions can this be? And we're only going to deal with the one that we're going to deal with. So this is where things get very, very interesting. So I think we're going to use a when matcher. When the current token dot type. So the only situation where we're going to have a binary expression is necessarily we're going to have an expression, then an operator, then another expression. So let's have a quick look at our expressions. So assignment, literal. In this case, we're going to be expecting a literal. So that would be like the name of a variable, for example, as one potential outcome. Hey, what's up, Kobena? I'm doing pretty well, although I'm really busy with this parser stuff and living in the city. So it's been a lot, but I'm doing really well. How are you doing, man? Okay, so token type is literal. Oh, no, token type dot literal. Just need to import that. Oh, it needs to be a kind of literal. That's a problem. Oh, здравствуй, Григорий. Как дела? Я понимаю русский сейчас. A little bit. Token type dot I think identifier. So this is something I was actually trying to figure out earlier. Now I'm wondering why my autocomplete isn't working here. Did I remove identifier as a literal? Oh, holy crap. Thank you, Grigori. I really appreciate that. Большое спасибо. I think that's correct. Yeah, I've been studying Russian for months now. Красивчик. Okay. I think I imported the wrong token type here. Okay, donk. This is behaving weirdly. Well, we're off to a great start, folks. I guess it didn't like the is statement there. Let's just token type. Do I seriously have to import that? That was really confusing. I don't know why I wasn't importing that properly. Okay, so identifier, is that what I did in the test? Yes. Okay, so we're expecting it to start with an identifier as one example. So if it starts with an identifier, one of, it can either be it can be a binary expression. I think it can be a unary expression. No, it wouldn't be a unary expression because that would start with a operator. Yeah, this is going to get tricky. Yeah, at this point I'm going to have to only worry about the very unit that I'm coding and not really worry about dealing with other issues right now, because I don't really know the general process of doing this. So let's just deal with what's right in front of us. So in the case of an expression, binary expression, we're expecting an identifier token, and then we want to maybe say match binary expression. And from there, we're going to probably again say current token and tokens. We might end up consuming the, no, I don't think we would consume the identifier at this point, but we'll see. Okay, let's do that. Private fun. Grigori says, I remember your videos about recycling review from 2018 or something. They helped me a lot to start developer career, so thank you again. It's nice to see you online. Really happy to hear that, Grigori. Yeah, it's been a long time. I started making videos back in 2016, and when I started making videos, I had this idea that if I just pretty much focused on quality of information and almost nothing else, that viewers and subscribers and things like that would show up. And I've come to understand that that was a very mistaken ideal, and if you want to be successful on something like YouTube, you definitely need let's see, this is going to be a list of tokens. You definitely need to be active on social media and all that kind of stuff, unless you have really unique content and you kind of go viral. So it's been a slow progression, but I've always tried to prioritize quality of information above everything else, and I've always tried to know what I'm teaching and know what I'm talking about. Thank you, Grigori. I really appreciate that. I owe you a beer or a shot. Anyways. Okay, match binary expression. So for a binary expression, we expect to see an identifier, an operator, and then another identifier. I think I'm doing this properly, but we're going to see. Binary expression. Now, it's not necessarily an identifier is an important thing to mention here. It can be an expression. Okay, so match binary expression. So we're going to look at the first token, and we're going to say when token. So yeah, this is wrong. It doesn't necessarily just have to be an identifier, because it can be an expression. This is where things are going to get super interesting. So in the first token, identifier, then what we need to do is we need to look at the next two tokens. So we're going to say the next thing needs to be an operator. So I think I want a helper function here. Private fun, say is operator. It's going to work on a token. Why don't we make an extension function just for fun? Let's say donk token dot is operator, and then we'll say if when this dot type is so first example would be plus. Let's look at our operators here. So in this case, it can be plus, minus, slash, asterisk. Okay, we'll start with that. Plus, minus, slash, asterisk. And then it can be other things. It could be the equal, double equals. So equal. Gregorias, have you read Java concurrency in practice, or what did you use to learn advanced concurrency topics? Like semaphores or thread pools? So practically speaking, I learned how to use the executors framework, Java executors framework, from Douglas Schmidt. He has a tremendous YouTube channel. I'll write it that way, Douglas Schmidt. I found his Java stuff on concurrency to be very, very useful, and I find the Java executors framework is a really good level of abstraction for concurrency in Java, because I find threads are a little bit too low level. Now, in terms of semaphores and concurrency primitives, that I learned from a book called Operating, I'll write it here, Operating Systems 3 Easy Pieces. A pretty technically dense book, and I learned it in C, so it wasn't Java, but I found that to be a relatively good resource for learning concurrency primitives. But yeah, hopefully that kind of answers your question. His name is Grigori, Mr. Worldwide. Also, at some point I will be resuming my live stream Q&A, and I've been an Android developer for nearly a decade, so definitely stop by and or keep an eye out for my live stream Q&As, because I'd be happy to help you with Android questions there. Okay, so we've got equals, equals. I'm not sure, I don't think assignment probably shouldn't be considered binary, even though it kind of looks like a binary expression. Swaminath asked about coroutines. For coroutines, Roman Elizarov's talks. He's the current project lead for Kotlin. He has some really good talks on coroutines. And structured concurrency is really useful. The thing about coroutines is, to an extent, you can almost make them as complicated or simple as you want them. But understand that anytime you're working with concurrency in programming, it's not going to be simple. It's not going to be easy if you're looking at coroutines. It's not going to be easy if you're looking at threading. But once you kind of wrap your head around what you're doing, then it is easier. Once you're happy with one way of doing concurrency, it sort of makes it easier. At least that was my experience. Okay, so we've got, where are my token types? So we've got equals equals, exclaim equals for not equals. We've got less. We've got greater. We've got less equal. We've got greater equal. And I think that's everything. Equal will be for our assignment expression, if I'm correct. So I think that's everything we can expect from a operator here. Now what we need to do here is true, else, false. And I gotta tell you, I love the syntax of the when statement in Kotlin. It is so beautiful. It's so nice and idiomatic. Like, look at that. Okay, so if it's one of those, we return true. Otherwise, we return false. Cool, great. Everyone's happy. So I feel like okay, I must have wrote this in the wrong spot. Match binary expression. No, that was correct. Mr. Worldwide asks, aren't most languages made in C/C++? Why am I using Kotlin? So there's a number of languages, a number of reasons. So it's sort of true for the most part that many languages, the compilers for those languages are at least partially implemented in C or C++. So the reason why I'm using Kotlin, there's a specific reason. So I actually intend to target WebAssembly with this particular language. I don't really plan to basically compile to machine code. So the reason for that, so given that I don't want to compile to machine code and do something where I have to use basically a tool called LLVM to compile to various backends for me, given that I'm doing that, it just made a lot more sense to write this code in Kotlin instead of C. I can read and write C and C++, but they're not as nice and pretty and easy to write as with the Kotlin programming language. And Kotlin has, just with its compiler and the backend tools you can use with it, it just seemed like a really good match. So primarily I'm doing this as a learning project, and the fastest way for me to write a usable compiler, or I guess it might even technically be an interpreter, but we'll see, was to do it in Kotlin. I could have written it in Python, but I'm not a fan of Python, and I don't really like JavaScript that much either, so it was pretty much either going to be TypeScript or Kotlin, and I just prefer Kotlin. Okay, so we want to we're expecting an operator. So if we see an identifier, then the next thing we want to do is we want to see an operator. So we're going to say if we'll say if tokens, so the next token current plus 1 dot is operator, and by the way, I'm totally making this code up as I go. Tokens current plus 2, so the next token, dot type equals identifier, then we should be okay to build and return a binary expression, I think. Ooh, that's something I love to harp on. So Cigar asks, hey Ryan, this is the first time I joined live. I learned a lot of things from you, basically clean architecture, solid principles. I can see that you used enum in this app. Is it not doubles the memory? Does it not double the memory? So this is one of the big problems with Stack Overflow is you'll get people, I'm not sure if you got this from Stack Overflow, but this is most commonly where this idea about enums comes from. So the basic idea is that using enums in your code doubles the amount of memory as opposed to using, like, I don't know, static constants or something like that. So you've got to understand that when someone says, so two things. Number one, it depends on the JVM, if we're talking Java JVM code, which we are right now. So number one, it depends on the JVM. Different JVMs optimize enums differently, and same for the case of the, what does Android use right now? ART, Android runtime. So the Android runtime that's currently used actually optimizes enums, so it's not even really an issue. Number two, when it is an issue, when we say it doubles the memory, we're talking of a difference between, for example, something of the order of, like, we're using 32 bits instead of 16 bits for each element in the enum, as opposed to using a whole bunch of different string constants. So really what I'm saying here is there's an expression, it's like pissing in the ocean. On a modern computer system, this difference of 32 bits instead of 16 or 64 bits instead of 32 bits for every item in an enum is literally like pissing in the ocean. It's not going to make a difference. So just so you're aware, this whole thing about enums is almost entirely bullshit. It's sometimes, but not always, technically true that the memory footprint can be double compared to just using like individual strings or something like that. But when it is true, the difference is so small that it's just silly. Unless you're, contextually speaking, if you are trying to write code which is so sensitive to performance that you need to be worrying about that kind of thing, then you might want to worry about enums. But if we're talking in the context of like GUI application development, things like Android, number one, the Android runtime in particular optimizes for enums to reduce the memory impact. And secondly, it's just not going to be an issue. That's a very good question though, and I get that a lot. What enums do is they make your code more legible and resistant to change. In other words, they make your code more legible and immutable, and that is incredibly useful in certain situations, particularly when you have a set of restricted values. So for example, our token types here. So don't worry about memory in enums unless you're literally counting bits to improve memory, and you almost definitely aren't doing that. Grigori asks, by the way, do you know something about things like Jvm Internals, bytecode, and other low-level Java stuff? Can you share some resources to learn those topics? I know a little bit about Jvm Internals. I'm a little rusty on it because I researched it about 2 years ago for my Java programming course. But basically, you're very welcome, Sagar. I think, honestly, for the internals of the JVM, I did have to actually go through the Oracle specification on JVMs, which is very dry and difficult to get through. And then what was really frustrating to learn is that there's lots of different JVMs. So there's like the Open JVM, there's the Oracle JVM. I guess, so these are parts of the SDK. And it was kind of frustrating to learn that anything I learned about the Oracle JVM or SDK, Java SDK, might be different from the Open SDK, which some other companies use. So yeah, and then the other thing that helped me was seeing how a virtual machine and language was built. So if you look up, what was it called? Creating a programming language. It's a series of live videos on YouTube. In that, the programmer who makes it, I can't remember his name. Jonah is a dev, I think. He creates a sort of kind of like an assembly language and a virtual machine. And in learning how he did that, it kind of cleared up how virtual machines work a little bit for me. That's basically it. Anyways, I should really stop writing this stuff in the Java doc comments. But yeah, I wouldn't consider myself an expert on Jvm internals, but I do know a little bit about it. Okay, so anyways, back to our coding here. So we're expecting an identifier is one of the things that could occur, then an operator, then an identifier. And if we have those things, then we should be able to create our binary expression. No worries, Grigori. Okay. So binary expression. So left will be tokens 0. Operator will be tokens 1. And then tokens 2. Now I'm not actually doing that properly. That should be current plus 1, current plus 2. And then this thing needs to be wrapped inside of a pair. And the pair is going to have to include the appropriate offset. Oh, that says 22. That's not right. That would have been fun. Three. I think we offset it by 3. This value we return here is going to end up back in our loop as what we're going to increase the current value by. So I think what we need to actually do here is we say this equals, can I say, yeah, plus equals parse.second? Okay, and then that will move our current over for the next iteration of the loop. So I think that's how that works there. This thing is complaining. First is a binary expression, second is an int. So why is it complaining? Because I don't have a return type. That would probably do it. This be an expression. I think here it would be an expression. Expression, yeah. And then int. Now it doesn't like this. Why doesn't it like that? So I need to make this into a base expression. Maybe a variable expression? Yeah, this is the part where I like scarcely know what I'm doing here. I guess a variable expression is what it should be. We're going to find out. Okay. All right. So that's one example. And then if none of those work, then we need to return like an error. So return error statement. Maybe I need an error expression as well. No, that's not going to work. Okay, I don't even know if this is a good idea at this point, but let's just give this a shot. We have void expression, so I think this makes sense. One of the difficult things that I'm doing, sorry for picking my nose here, one of the difficult things that I'm trying to do is because I am avoiding shared mutable state and I'm also not using try catch to manage error flow, it means that instead of using try catch, I have to actually internally represent the errors using a subclass of my the types that I'll be working with. So this is going to be an error expression. This needs to be expr, and we need to add that into our visitor. This is the visitor pattern, by the way. No, error expression. Okay. Happy? Why is it not happy? Oh, because it's a statement visitor. There we go. Okay. Sorry, I just need to fiddle around with that. So we've got an error expression. This is going to be one of those horrible coding sessions where I'm not sure if I'm going to have to like rewrite most of this code. But sometimes you just have to dive in and do it. Okay, so this is going to be a parser exception, and our message is going to be unable to parse binary expression. And then let's say from, and let's get a little cute here. Let's say I just realized I'm probably going to have to null check I could see myself getting an list out of bounds exception here. If we check, for example, current +1 and it's the end of the list. So I'm going to slap a big fat to do here. Decide how to handle index out of bounds. But one problem at a time. Okay, unable to parse binary expression from I was going to do something cute where we have like, I sort of in the error message mentioned the tokens, but I just remembered if we do have an index out of bounds, then that's actually going to crash, so I don't want to do that. So let's, for now, we're just going to say unable to parse binary expression. And we're going to return 1 for now, because I don't really know. Oh, that shouldn't actually go there. Okay, and that's all we're going to do for now. Okay. So here's our expression statement. So we say match bin result if match bin result dot come on brain, you can do this. Match bin result dot first, which is the base expression, does not equal we should say dot type, does not equal hold on a minute. Error expression, I guess. Can you do that? Do you do not is? I think that's how you do that. I've never actually written not is in Kotlin, but that's kind of cool. Okay, so this is supposed to say is not an error expression. Then we can create our binary our expression statement, which is what we're trying to return here. So we say return expression statement from our match bin result dot first. This gets wrapped again in a pair. And then we return the match bin result dot second. And I think we actually just skip along. Probably we would return an error statement here, but I'm not sure. So anyways, what I'm going to do at this point is I have some kind of code here. I'm not sure what it does, but we're going to run our test to see if it actually does what I want it to. And probably it doesn't, but that's the joy of test-driven development. Just want to check something real quick. And as expected, we have an index out of bounds exception, which is pretty hilarious. Cigar asks, to avoid mutable state, is a program not hard to understand? I actually find exactly the opposite to be the case. I find shared mutable state, so in this case the use of global variables, to be much harder to follow and understand than the way I'm doing it, where essentially every piece of data gets piped through a function. So you can actually follow the flow of the data and the transformations of the data really easily. Whereas if you imagine that every one of these functions here did not have anything passed into it, but rather worked with shared mutable state, I find that very difficult to follow in complex code. But I guess that might be a little bit to do with how my brain works. When I'm programming, I have to actually visualize the code mentally, and I actually have to be able to visualize the data flowing through the different functions and stuff like that. Whereas I understand some people have different ways of thinking about code. So probably it has a lot to do with personal preference, but that's my opinion. Okay, so we had an index out of bound exception, which is exactly what I thought was going to happen, hilariously. I think it was actually in the... Oh, it was here. My first gut reaction is that probably we should not be using for each here. In fact, we should definitely not be using for each here. What did I use in the scanner? Did I just use a for loop? No. Okay, I see. Let's do that. So the problem is I had a for each loop, so that's not going to work because we're supposed to parse some tokens, consume that, and then start at an offset. By using a for each loop here, I'm going to parse 3 tokens, but then I'm going to start at the second token, and then I'm going to parse 2 tokens, and then it's just going to blow up. So I definitely can't use for each here. Now, what is at end? Is that just like a helper that I wrote? That should be publicly visible. Okay, that doesn't make any sense to me. I think it just needs to import, because internal, it's in the same module, so it should be able to figure this out. Donk dot scanner dot I'm not actually sure. Let's just try that. Oh my god, are you serious? Ah, this is annoying. So the reason why I'm annoyed is this extension function should be visible. Internal is module level visibility, not package level, and it's in the same module. Maybe if I put it somewhere else. Okay. How about now? Yes. That was annoying and didn't make any sense whatsoever, but that's okay. Maybe it was glitching because there was an error inside of the parameter here. That actually could have been the problem. Tokens.size. Okay. All right, so now instead of using for each, we're using a while loop, and we actually detect when we're at the end. And then hopefully that will break less. Let's have a look. Okay, still getting an array out of bounds exception. So current starts at 0. So what we're going to do is we're going to run the debugger just to see the exact state of the data at the error. Now the problem appears to be we're asking it for the value at index 3, which isn't going to exist, plus 2. We shouldn't really be calling this twice. So I think what's happening is we're not passing the value. Have a good night, Swamana. Thank you for joining me. Okay, I think something is like really breaking. I suspect we're returning errors or something like that. Let's just see if that's the case. Yeah, it's not parsing. Okay, I get what's going on. Okay. All right, well, you know what, folks? I've been streaming for about an hour and 20 minutes here. We've got started with our test-driven development process on the parser, and I've got started writing it, but I think I'm going to call it a day for today, because there's a couple really critical things that I'm going to have to figure out to do with this code, and I'm not entirely sure how well this approach is going to work. So what I'm going to do is I'm going to sign off for now, and I'll do my best to, once I have a more solidified approach here and I'm more confident it's going to work, I'll try to live stream some more work on this thing, but I think that's enough streaming for today. So thank you for the few people who came to watch. And at the start of this episode, I rambled about what we did in the previous one and gave an overview of the Lexer/scanner process and then the parser process. When I say process, I don't mean in the computing sense of the word. But yeah, I think that's going to be it for today. Thank you.